Hello friends, in today's video I will show you not the complete codes but just simple the for loops, and we will calculate the time complexity for that. So here, as you can see, I have written three examples first of all for you, and later on we will discuss the further examples and we will calculate the time complexity for that. So just without wasting time, we will move forward to our examples. So the first example here is our for loop. Here I is initialized with 0. So I is starting from 0, and it will the condition here is I is less than n. So till I is less than n, this loop will get executed. And again we are incrementing the I here. This was our loop, and then this statement is executing, right? So we have to analyze how many times this statement gets executed. This is our main task. So if I take a look at this, how many times this loop is getting executed. So this is getting executed n plus 1 time, right? And this statement gets executed as n times. So our main task here is that how many times this statement gets executed. We don't have to do anything with this one, n plus 1, so you can simply avoid it, right? So in order to calculate the time complexity, the main thing is that how many times our statement gets executed. So we can write the complexity here is order of n times, right? So this was about this first example, that how many times this statement gets executed, right? So moving forward to the second example, the second example is also same like the first one, but here we have just changed the values. Here I is starting from the n, initialized with n, right? And then the condition we have changed it until I is greater than 0. So this loop will get executed, and we have decremented the I over here. And the main task here again is that we have to find out how many times this statement is getting executed. So here the complexity will again be same. It will be order of n times, right? So in order to calculate the time complexity, the main task is that how many times your statement gets executed. You don't have to do anything, you don't have any concern with how many times the loop gets executed, right? So now moving forward to the third example, here you can see that I is starting from 1, I is initialized with 1, and the condition is until I is less than n, so this loop will get executed. And we are incrementing the I 2 times. I is equal to I plus 2, and we have to calculate how many times the statement is getting executed. So here the statement will get executed by n by 2, right? So in order to calculate the complexity, the time complexity over here, you can see that the degree of the polynomial here is 1. So the order, the time complexity will be order of n times, right? If I make a bit changes in the loop here, and I make it as I is equal to I plus 20, so this will become n plus 20, right? But here again you can see that the degree of the polynomial here is 1, so the time complexity here will be order of O of n. This will be 1, right? So if it does not matter what is in the base, what matters is the degree of the polynomial. So now we will discuss another example, and we will calculate the time complexity for that. Okay, so now coming to our next example. So you can see here we are having the nested loops. Up till now we have studied the simple loops, the single loops or for loops, not the complete codes, and here again we are having just the loops. But the main difference is that now we are having the nested for loops, right? So this will get executed for the, we are already familiar with such loops. So this will execute it for n times, this will get executed for n times, and the first one will actually get executed for the n plus 1 times, right? Like this. And the second one will get executed for, as it is the nested loop, so after the first one gets executed, so it will comes into the inside the second loop, so this will get executed for the n plus 1 times, right? So here our statement will get executed for n into n times, as it is a nested loop, right? So this will get executed for the n into n times, so we can avoid this and this, as we have already discussed that the main concern is that how many times our statement gets executed. We don't have to do anything that how many times our loop gets executed, right? So we can write the time complexity for it as order of n square, as it is n into n times, so we will write it as n square, right? So moving to the next example, and let's calculate the time complexity for that. Here you can see that we are having the p is equal to 0, I starting from 1. Here you can see that the condition is a bit tricky and confusing. P is less than or equal to n, so you can see that it's not I is less than or equal to n and then I gets incremented. The statement is p is equal to p plus 1, right? So the p is starting from 0, and every time 1 gets added into it, I gets added into it, right? So we don't know how many times I gets executed over here, so don't get confused. So it's simply getting executed for n times, right? This will get executed for the n plus, this will get executed for n plus 1 time, and the statement will get executed for the n times. So we will write it n times, and then we will write the time complexity, the order, it will be the O of n, right? We will close it, right? So don't get confused if you are given some value of the any other variable and it's mixed in the loop, as it was in our previous example. Like here I was replaced with p, so don't get confused in such examples. So this was all about the time complexity, where we shared a few for loops, not the complete codes, and then we calculated the time complexity for that. So we will discuss some more example in the upcoming videos, and we will calculate the time complexity for those examples, right?